Lesson 4.9 is on slopes of parallel and perpendicular lines. So in this lesson today, we are going to identify and graph parallel and perpendicular lines, write equations to describe lines parallel or perpendicular to a given line. So we'll talk about parallel lines and perpendicular lines today. So why learn this? Parallel lines and their equations can be used to model costs, such as the cost of a booth at a farmer's market. To sell at a particular farmer's market for a year, there is a $100 membership fee. Then you pay $3 for each hour that you sell at the market. However, if you were a member the previous year, the membership fee is reduced to $50. So here, the red line, in your book it's red, it's this top line, shows the total cost if you're a new member because you're being charged $3 per hour plus that $100 membership fee. And then the blue line, which is going to be the bottom line, shows the total cost if you're a returning member. So $3 per hour plus that $50 membership fee. These two lines are parallel. They're parallel because they're never going to intersect. They have the same slope. So parallel lines are lines in the same plane that have no points in common. In other words, they do not intersect. So these two lines are never going to share the same point. They're never going to cross. And that's why they're parallel. And in order to identify parallel lines when we're looking at equations, they'll have the same slope. So now we're going to go ahead and look at example 1. So parallel lines, just a few things to note. Two different non-vertical lines that are parallel if and only if they have the same slope. So having the same slope is going to be important. So here we have y equals 1/2 x plus 5 and y equals 1/2 x plus 1. They both have the same slope of 1/2, so that means they are parallel. All different vertical lines are also parallel. So if you have a vertical line going up and down, like x equals -2, x equals 4, they are parallel. They're never going to intersect. So example 1, we're going to look at identifying parallel lines. So we're going to identify which lines are parallel. So we have y equals 4/3x plus 3, y equals 2, y equals 4/3x minus 5, and then y equals -3. And they're all in the graph here. So the first one, y equals 4/3x plus 3 is right here. Y equals 2 is this horizontal line. Y equals 4/3x minus 5 is right here. And the last one is y equals -3. So immediately you should be able to visually see which ones are parallel. Okay, they're going to be lines that kind of run right along each other, but they're never going to intersect. So here, this line and this line are parallel because they have the same slope. They both have the slope of 4/3. So that means the lines described by y equals 4/3x plus 3 and y equals 4/3x minus 5 both have the same slope of 4/3. So these lines are parallel. Then these other two lines that we have, the horizontal lines, we have y equals 2 and y equals -3. They both have a slope of 0. So these lines are also parallel. Okay, so we have two sets of parallel sides. These ones that are kind of increasing from left to right, and then these two horizontal lines. Now we're going to look at part B, continuing to identify which lines are parallel. So in the last example, we could visually look at the graph and identify which ones are parallel. But sometimes you're going to be given just the equation. You can graph them if you want to, but you might not always have graph paper handy to graph them. So when you look at these equations, the easiest way to compare them and identify their slope is to write it in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m here is going to be our slope. So we have y equals 3x plus 2. That's in slope-intercept form. My slope here is 3. So 3 is the slope. y equals negative 1/2 x plus 4. Slope-intercept form already, so that means my slope here is this negative 1/2. The third equation, x plus 2y equals negative 4. That's not in slope-intercept form, so we're going to have to rewrite it. So we're going to start by getting this 2y by itself, so subtract x from both sides. So we're going to get 2y equals negative x minus 4. And then I just want 1y, so I'm going to divide both sides by 2. 2 divided by 2 gives me 1y. And then here I'm going to break it into two parts. I'm going to have this negative x over 2 and then minus 4 over 2. So negative x over 2 is going to give me a negative 1/2 x, and then minus 4 over 2 simplifies to 2. So my equation is y equals negative 1/2 x minus 2. And here my slope is negative 1/2. The last equation is y minus 5 equals 3 times the quantity x minus 1, not in slope-intercept form. So I'm going to go rewrite that into slope-intercept form. So first I have to distribute this 3. So 3 times x is 3x minus 3 times 1 is 3. So I have y minus 5 equals 3x minus 3. And then to get y by itself, I'm going to add 5 to both sides. Minus 5 plus 5 gives me 0, so I'm left with y. Bring down my equal sign, and then I have 3x minus 3, or negative 3 plus 5 gives me a positive 2. So I'll have 3x plus 2. So here my slope is 3. So m equals 3. So now to figure out which lines are parallel, you have to find the ones that are the same slope. So y equals 3x plus 2 has a slope of 3. The fourth equation also has a slope of 3. So these two are parallel. And then this one, my second equation, has a slope of negative 1/2. My third equation also had a slope of negative 1/2. So those two are parallel. So that is example 1. There are 2 check it out problems for you to do. Identify which lines are parallel. So go ahead, take a moment, try these 2 on your own, and then resume when you are ready to check your answer. So for A, my first equation, y equals 2x plus 2. Already in slope-intercept form, my slope is 2. The second equation, y equals 2x plus 1, already in slope-intercept form, so my slope is 2. And then I have the equation y equals negative 4, slope-intercept form, x equals 1. So here, the only 2 equations that are going to be parallel are the first 2. So y equals 2x plus 2, y equals 2x plus 1. Because when y equals negative 4, my slope is going to equal 0. And then when x equals 1, my slope is undefined. So the equations y equals 2x plus 2 and y equals 2x plus 1 are parallel. Part B, first equation, y equals 3/4 x plus 8. Already in slope-intercept form, my slope is 3/4. The second equation, negative 3x plus 4y equals 32. I need to go rewrite that in slope-intercept form, so I'm going to isolate that 4y by adding 3x to both sides. Negative 3x plus 3x gives me 0, so I'm left with 4y. And then on the right-hand side, I have 3x plus 32. Then I need to divide both sides by 4. So y equals, I'm going to break this into 2 parts. So we're going to have 3/4 x plus, and then we have 32 divided by 4, which gives us 8. So here, my slope is 3/4. So we did our first equation, second equation, third equation, y equals, I'll put that over here, y equals 3x. Okay, slope-intercept form, my slope is 3. And the last equation, we have y minus 1 equals 3 times the quantity x plus 2. So first I need to distribute that 3. So 3 times x is 3x. 3 times 2 is 6. So I have y minus 1 equals 3x plus 6. Add 1 to both sides to get y by itself. Minus 1 plus 1 gives me 0, so I'm left with y. And then I have 3x plus 7. And my slope here is 3. So in this equation, I have 2 sets of equations that are parallel. So the first one, or the first two, I should say, are these two right here. So y equals 3/4 x plus 8 and negative 3x plus 4y equals 32. And those are parallel. And then the second set of equations, y equals 3x and y minus 1 equals 3 times the quantity x plus 2, are also parallel. So now we're going to go ahead and look at example 2. Geometry application. So it says show that ABCD is a parallelogram. So here we have a shape on our coordinate plane. We don't know if it's a parallelogram yet, but remember in a parallelogram opposite sides are parallel. So this side AB needs to be parallel to DC. AD and BC need to be parallel. So first, we are going to use the ordered pairs and the slope formula to find the slopes of AB and CD. So AB is right here, so I'm going to take my y values, so 7 minus 5 over 4 minus negative 1. 7 minus 5 is 2. 4 minus negative 1 becomes 4 plus 1, which gives me 5. So slope is 2 over 5. And then I'm going to repeat that process with CD. So I have 3 minus 1 over 4 minus negative 1. 3 minus 1 is 2. 4 minus negative 1 is 4 plus 1, which gives me 5. So here both my slopes are 2/5. So that means AB is parallel to CD because they are the same slope. Then AD, we have to prove AD and BC are also parallel. Because remember, opposite sides are parallel, in a parallelogram. So I already proved AB and CD are parallel. AD and BC are both vertical lines. So that means they have the same slope. So they are parallel. So since we proved that both sets of sides are parallel, this is going to be a parallelogram because both pairs of opposite sides are parallel. There's a check it out problem for you to try. It says show that the points A, 0, 2, B, 4, 3, or 2, C, 1, negative 3, and D, negative 3, negative 3 are vertices of a parallelogram. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. All right, so I need to prove that AB is parallel to CD. So I need to look at these 2 points and find, or these 2 lines and find the slope to see if they're going to be parallel. Then I'm going to do the same thing. So when you think about your shape, okay, this is going to be a rough sketch. This isn't what it's going to look like. but you always label it A, B, C, D, like this. So we're going to prove that AB and CD are parallel, and then we're going to do AD and BC. So starting with AB, okay, my 2y coordinates, so I'm doing line AB, and I'm finding the slope of that. So 2 minus 2 over 4 minus 0. 2 minus 2 is 0. 4 minus 0 is 4, so my slope is 0. So now I'm going to do line CD. So I'm going to have negative 3 minus negative 3, and then negative 3 minus 1. Negative 3 minus negative 3 will become negative 3 plus 3, which is 0. Negative 3 minus 1 is negative 4. 0 divided by negative 4 is 0. So here, AB and CD are parallel. So line AB and CD are parallel. Now I need to look at my other set of points. So AD and BC. So we have to see if those two sets of sides are parallel. So starting with line AD. So my y values, I have negative 3 minus 2. And then my x value is negative 3 minus 0. So negative 3 minus 2 gives me negative 5. And then negative 3 minus 0 is negative 3. And a negative divided by a negative is a positive, so this will be positive 5 over 3. Now I need to do line BC. So I have negative 3 minus 2 over 1 minus 4. Negative 3 minus 2 is negative 5. 1 minus 4 is negative 3. And again, a negative divided by a negative is a positive. So both AD and BC have the slope of 5 over 3. So that means line AD and line BC are parallel. So since we have two sets of opposite sides that are parallel, this means the shape ABCD is a parallelogram. So far we've looked at parallel lines. Now we are going to look at perpendicular lines. So perpendicular lines, let me get my focus back. There we go. Perpendicular lines are lines that intersect to form a right angle, 90 degrees. So they just cross at a T. So to describe this in words, two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. Vertical lines are perpendicular to horizontal lines. So you need to remember that when you multiply their slopes, the product is negative 1, and then vertical and horizontal lines are automatically perpendicular to each other. So we're going to start by looking at example 3. So identifying perpendicular lines. So identify which lines are perpendicular. X equals negative 2, y equals 1, y equals negative 4, y plus 2 equals 1/4 times the quantity x plus 1. So here's a graph of all those lines. So x equals negative 2 is right here. Y equals 1 is this horizontal line. Remember, vertical and horizontal lines are perpendicular, so those two are going to be automatically perpendicular. And then we have y equals negative 4x, which is right here. And then y plus 2 equals 1/4 x minus 1. So, first, x equals negative 2 is a vertical line, and then y equals 1 is a horizontal line. So those are going to be perpendicular. Y equals negative 4x. The slope is negative 4. And then the slope of the line described by y plus 2 equals 1/4 x minus 1 is going to be 1/4. So in order to get that slope, you need to rewrite your equation. So I have y plus 2 equals 1/4 x, quantity x minus 1. And I'm going to distribute that 1/4. So we get 1/4 x. And then 1/4 times 1 is 1/4. So y plus 2 equals 1/4 x, and then subtract 2 from both sides. So y equals 1/4 x minus 2 1/4. So your slope here is 1/4. So now, in order to tell whether or not they're going to be perpendicular, you take the slopes, so negative 4 and 1/4, and multiply them by each other. And if you get negative 1, they are perpendicular. If you get anything else, not perpendicular. So negative 4 times 1/4. I'm going to write negative 4 over 1 and then multiply across. Negative 4 times 1 is negative 4. 1 times 4 is 4. And negative 4 over 4 simplifies to 1. So that means they are perpendicular because the product of their slopes is equal to negative 1. There is a check it out problem for you to try. It says identify which lines are perpendicular. Y equals negative 4. Y minus 6 equals 5 times the quantity x plus 4. X equals 3. Y equals negative 1/5 x plus 2. So go ahead, take a moment, pause the video, try this on your own, and then resume when you're ready to check your answer. So right off the bat, you should see y equals negative 4 and x equals 3. One's a horizontal line, one's a vertical line, so they are perpendicular. So y equals negative 4 and x equals 3 are perpendicular. My other two lines, I need to find their slopes. So first, y minus 6 equals 5 times the quantity x plus 4. I'm going to distribute that 5, so 5 times x is 5x. 5 times 4 is 20, so plus 20. Y minus 6 on that side, and I'm going to add 6 to get y by itself. So y equals 5x plus 26. So my slope here is 5. And the last equation, y equals negative 1/5 x plus 2. My slope is negative 1/5. So in order to tell whether or not they're perpendicular, remember you have to multiply the two slopes together to see if you get negative 1. So I'm going to multiply 5 and negative 1/5. So I'm going to write this as 5 over 1 and multiply across. So 5 times negative 1 is negative 5. 1 times 5 is 5. And negative 5 divided by positive 5 gives you negative 1. So that means those two equations are indeed perpendicular. So y minus 6 equals 5 times the quantity x plus 4. And y equals negative 1/5 x plus 2 are perpendicular. And that is a 5. I apologize. Looks a little sloppy. So now we're going to go ahead and look at example 4. Example 4, we're going to do a geometry application again. So it says show that PQR is a right triangle. If PQR is a right triangle, PQ will be perpendicular to QR because we're assuming or predicting that this is going to be the right angle here. So PQ and QR, we need to see if they are perpendicular. So all we need to do is find the slopes of those two lines, and then if they multiply together to give us negative 1, then they are perpendicular. So starting with PQ, we're going to subtract our y values, so 3 minus 1 over 3 minus 0. 3 minus 1 is 2. 3 minus 0 is 3. So the slope is 2/3. QR, we're going to subtract our y value, so 0 minus 3. And then 5 minus 3. 0 minus 3 gives us negative 3. And then 5 minus 3 is 2. So the slope is negative 3 over 2. And then to multiply these together, we would do 2/3 times negative 3 over 2. 2 times negative 3 is negative 6. 3 times 2 is 6. And negative 6 over 6 equals negative 1. So they are perpendicular to each other, because when you multiply them together, you get negative 1. There is one check it out problem for you to do, so go ahead, take a moment, pause the video, and then resume the video when you are ready to check your answer. So here, we don't know where the right angle is or where it might be, so we have to find the slope of all 3 of our lines. So I'm just going to draw a triangle to help us identify our lines. So it's going to be P, Q, R. It's always in alphabetical order. So we're going to have PQ, QR, and RP. So we're going to start by finding the slope of all of them. So starting with PQ, I'm going to do 6 minus 4 over 2 minus 1. 6 minus 4 is 2. 2 minus 1 is 1. 2 over 1 equals 2. Then, so I did PQ, now I'm going to do QR. So QR, so I'm going to do 1 minus 6 over 7 minus 2. 1 minus 6 is negative 5. 7 minus 2 is positive 5. And negative 5 divided by 5 gives us negative 1. Now I have RP. So to subtract our y values, so 4 minus 1, and subtract our x values, 1 minus 7. 4 minus 1 is 3, and then 1 minus 7 gives us negative 6. And this simplifies to negative 1/2. So now I need to decide where my right angle might be. Remember, when you to decide, you have to look at what 2 slopes are going to multiply together to give you negative 1. So the 2 that will multiply together to give you negative 1 are going to be the PQ and the RP. Because if I write 2 and multiply that by negative 2, oops, I'm going to write 2 over 1. 2 times negative 1 is negative 2. 1 times 2 is 2. And this simplifies to negative 1. So this means PQ is perpendicular to RP. So that is where the right angle is going to be. So PQ is perpendicular to RP. So the right angle is going to be this RPQ. So the right angle is angle RPQ. So right here is where that right angle is going to be. We have one more example to do together. We're going to look at example 5. So we are going to be writing equations of parallel and perpendicular lines. So we're going to be given an equation, and then we want to write a perpendicular or parallel line to the information that we're given. So A, write an equation in slope-intercept form for the line that passes through 4, 5 and is parallel to the line described by y equals 5x plus 10. So it's parallel. If it's parallel, that means we are going to have the same slope. So my equation y equals 5x plus 10, my slope is going to be 5. It's the same slope. So now we're going to write the equation in point-slope form and then rewrite it in slope-intercept form. So we're going to have y minus y1, which is 5, equals 5, in parentheses, x minus 4. Then from here I'm going to distribute this 5, so I'm going to have y minus 5 still. 5 times x is 5x, minus 5 times 4, 20. And then I'm going to add 5 to both sides. Minus 5 plus 5 is 0, so I'm left with y. I have 5x. Minus 20 plus 5 gives me a negative 15. So my equation is y equals 5x minus 15. Part B, it says write an equation in slope-intercept form for the line that passes through 3, 2 and is perpendicular to the line described by y equals 3x minus 1. So here the slope is 3, but I want a line that's perpendicular. So to find the one that's perpendicular, you flip your fraction. So if you write this as 3 over 1, you're going to flip it and then do the opposite sign. So my new slope now is going to be negative 1/3. Okay? And a quick check, 3 over 1 times negative 1/3 is going to give you negative 1. So now we're going to write this in point slope form and then change it to slope intercept form. So y minus y1, so y minus 2 equals my slope, negative 1/3, times the quantity x minus 3. And now I'm going to distribute that negative 1/3. So negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 3, and negative times a negative is going to become a positive, and that's going to become a positive 1. Then I'm going to add 2 to both sides to get y by itself. Minus 2 plus 2 gives me 0, so I'm left with y. And then I have negative 1/3 x plus 1 plus 2 gives me a positive 3. So my equation is y equals negative 1/3 x plus 3. Now there are 2 check it out problems for you to do. So go ahead, take a moment, pause the video, and then resume the video when you're ready to check your answer. Pay close attention to whether it says parallel or perpendicular, because that's going to be really important with your slope. So for A, it says write an equation in slope-intercept form that passes through 5, 7 and is parallel to the line described by y equals 4x minus 6. So for A, it's parallel, so that means your slope is going to be the same. So my equation is y equals 4x minus 6. So that means my slope is going to be 4/5. So now I'm going to use point slope form. So y minus 7 equals my slope, 4/5, times the quantity, x minus 5. I'm going to have y minus 7. I'm going to distribute. 4/5 times x is 4/5 x minus 4/5 times 5, which will be 4. Then I'm going to add 7 to both sides. Plus 7 minus 7 gives me 0, so I'm left with y. And then I have 4/5 x minus 4, or negative 4, plus 7 will give me a positive 3. So my equation is y equals 4/5 x plus 3. B, write an equation in slope-intercept form for the line that passes through negative 5, 3 and is perpendicular to the line described by y equals 5x. So y equals 5x, my slope is 5. It's perpendicular, so slope is not going to be the same. Remember the trick, write it over 1 and flip it. So we're going to have 1/5, and then you take the opposite sign. So this was positive, so now it's going to be negative. And if you need to quick check to make sure when you multiply those together you get negative 1, please do. So I'm just going to do that real quick. So 5 over 1 times negative 1 over 5. 5 times negative 1 is negative 5. 1 times 5 is 5. Simplifies to negative 1. So my 2 lines are now going to be perpendicular. So now I'm going to use point slope form with negative 5, 3, and my slope negative 1, 5. So y minus 3 equals negative 1/5 in parentheses x minus negative 5. Minus and negative will become adding a positive, so I'm going to change this x minus negative 5 to x plus 5 before I distribute. And now I'm going to go ahead and distribute that negative 1/5. So negative 1/5 times x is negative 1/5 x. And then negative 1/5 times 5 will give me a negative 1, or minus 1. Then from here, get y by itself, so add 3 to both sides. So minus 3 plus 3 gives me 0, so I'm left with y. And then I have negative 1/5 x. Minus 1 or negative 1 plus 3 will give me a positive 2, so plus 2.